A breakthrough mission always requires project-specific solutions in mechanical excavation. dHerrenknecht develops, manufactures, and sells the entire range of tunneling machines. The drilling equipment has proved successful under all geological conditions and on all continents of the world for tunnel diameters from 10 centimeters to over 14 meters. Based on the specific requirements for building the Guadarrama tunnels north of Spain's capital, Madrid, dHerrenknecht designed the 9.51 meter diameter double shield machines. They will produce an approximately 30-kilometer long tunnel for a high-speed train through the Guadarrama mountain range. The two double shield machines rank among the technically most challenged tunnel boring machines in tunneling. They can be flexibly modified to the respective geology of the tunnel line, since they combine gripper principle and segment lining in a specifically coordinated process. Thereby, this type of machine is well suited for the excavation of long tunnels in hard rock with geological fault zones. The tunnel boring machines, which started excavation in October 2002, enable very high and continuous tunnel production, in addition to safe work conditions. Each of the 1.7 meter long tunnel sections can be excavated and lined in less than 30 minutes. In comparison, conventional machines with segment lining need twice the time. Following is the machine concept of the Double Shield TBM in its operational sequence. The tunneling takes place in protection of a thrust shield, which serves as a rock support until the tunnel lining is installed. In the rear part of the tunnel boring machine, the so-called tail skin, reinforced concrete elements are installed. These elements are called segments. They serve as univalve and final tunnel lining. In this way, the inside of the TBM and the personnel working there are always protected from the rock. The overall system of the Double Shield TBM in Guadarrama has a diameter of 9.51 meters and a length of approximately 250 meters. The Double Shield machine is a mobile tunnel factory. The backup system located behind the shield keeps the factory running. The control cabin of the tunnel boring machine is installed here. In addition, the backup system secures the supply for power, water, fresh air, as well as the just-in-time supply of the segments and building materials necessary for tunnel lining. A sophisticated and seamless logistics concept in the backup system is the condition for optimal performance. The Double Shield TBM owes its name to a special constructional design. In the front part of the machine is a forward-moving front shield. It permits an extension of the cutter head. The rear part of the machine is not moved during the tunneling progress. The reaction forces, torque and longitudinal forces, are transferred to the rock through the extended gripper shoes, which are located in the middle section of the machine. Due to the separation of the forces, the segments can be installed during the excavation process, in contrast to the conventional procedure. The continuous tunneling, thus simultaneous boring and installation of the tunnel lining, ensures high performance rates. Thereby, the auxiliary thrust cylinders only serve for the fixation of the segments. In fact, during the segment installation, as well as during the re-grip cycle when the rear section of the machine, including the gripper section and the tail skin, is pushed forward. After completion of a stroke, the gripper shoes are retracted and the rear section of the machine is pushed forward against the front shield with the auxiliary thrust cylinders. The re-grip phase takes only a few minutes. Subsequently, the next section can be excavated. The continuous excavation can only be performed in rock sections without fault zones, because the gripper shoes use the surrounding rock as counterbearing. Therefore, the telescopic front shield can only be opened in stable rock conditions. If the double shield encounters a section with fault zones, the telescopic front shield is retracted. The entire boring machine is pushed forward only by the auxiliary thrust cylinders, which are pushing against the tunnel lining. This kind of excavation is called discontinuous, since, as with a conventional shield, thrust with cylinders is only possible after complete installation of a segment ring. This operating mode ensures optimum security in faulty ground. In this way, the machine can be adapted to the geological conditions and permits optimum performance at any time. The challenging engineering process of the continuous excavation with a double shield requires additional detailed solutions in construction and mechanics. The cutter head is driven over circularly arranged electric motors, which are frequency controlled. These electric motors drive the cutter head via planetary gearboxes and pinions into an external bull gear, which is part of the 3-axis roller-type main bearing. The installed drive capacity amounts to 5,500 kilowatts. The entire drive unit with attached cutter head is located above the torque box cylinders in the steel structure of the front shield. By adjusting the torque box cylinders in horizontal and vertical direction, a shift of the overcut of the cutter head is accomplished versus the shield. This overcut is necessary in order to minimize the friction between rock and shield, to counteract impossible rock convergences, and to allow TBM control. Furthermore, it is possible to shift the cutter head longitudinally. This is provided by cutter head displacement cylinders, which have a stroke of 400 millimeters. They support themselves on the steel structure of the front shield. Due to the hydraulic control of the entire unit, it is ensured that the main bearing only receives a defined load. The longitudinal shifting can also be helpful when a blocked tunnel face is encountered. For example, to free the cutter head, or for the creation of a workspace between the tunnel face and the front of the cutter head. Of particular importance for the double shield is the transmission of the torsional moment resulting from the excavation and the required thrust forces between front shield and gripper shield. The thrust forces working in the longitudinal direction of the tunnel are produced by the main thrust cylinders, which connect the steel structure of the front shield and the gripper shield. The torsional moments developing from the tunneling excavation are transferred into the steel structure of the gripper shield via the torsional ring and 2 torque support cylinders. The torque support cylinders compensate thereby the relative motion between front and gripper shield. The floating gripper shoes are supported in the gripper shield. 2 heavy hydraulic cylinders situated between the gripper shoes press the gripper shoes from the shield against the rock. The thrust forces and torsional moments are transferred at the contact zones between gripper shield and gripper shoes. This provides an actuated bracing of the gripper shield against the rock and the final deviation of the forces. The cutter head of a Double Shield TBM is equipped with special cutting tools for hard rock excavation. Located in the cutting wheel, 60 steel rollers with a diameter of 17-inch, so-called discs, are rolling along the tunnel face by the rotating motion of the cutter head. Each individual disc presses against the tunnel face with 27T. the rock is crushed. The excavated material, the so-called chips, falls into the tunnel bottom. "12 buckets on the cutter head periphery pick up the muck. Via rotation of the cutter head, the muck will be lifted and transferred through the chutes into a conveyor, which is located in the center of the cutter head. The actual lining of the bored tunnel is performed in the rear area of the shield. A complete tunnel ring consists of 7 pre-finished reinforced concrete elements, so-called segments. Each segment is provided with a surrounding seal, which prevents the penetration of water into the tunnel. Placement of the segments is done by the erector. The erector is controlled by a portable manual control and with direct visual contact. The segments are lifted off the segment feeder by a vacuum suction plate. The erector is continuously supplied with segments by the segment feeder located in the tunnel invert. At their exact intended location, the auxiliary cylinders are retracted prior to setting a new segment. The segment is set and braced immediately in place along with the overall system by the extension of the auxiliary thrust cylinder. The 2 top segments and the segment key have a flank inclination of 15 degrees. The segment key is not laterally set, but pushed in place from the rear, precisely fitting its location. This concludes the setting of the ring, and the tunnel grows, ring by ring. Dherrenknecht, the technological leader in mechanical tunneling, has the know-how and the experience to realize each tunnel project. The company, situated in southern Germany, is the only supplier worldwide who can offer and market the entire range of mechanical tunnel boring machines, from 100 millimeters to over 14 meters in diameter. Hard rock machines, EPB and partial face machines, mix shields, as well as pipe jacking and HDD equipment made by Dherrenknecht accomplish successful breakthrough missions through all geologies around the globe. "25 years of experience and a worldwide service network make Dherrenknecht a competent partner."